Number 15, first we're going to convert transmittance into absorbance. So absorbance equals the negative log of the transmittance. We have two compounds. We have A and we have B. The absorbance, so at 2022 wave numbers, the absorbance of A is going to be 0.5086. So again, what I'm doing is I'm taking this percent transmittance is 31.0. Okay, so that means the T is 0.31. So I take the negative log of 0.31 and end up with this value. Similarly for B, percent transmittance is 97.4. So I convert that into absorbance and I get 0.01144. Same idea. So for, let's see, the other wave number, I'm at 1993 wave numbers. My absorbance is for A is 0.09854. And for B, I have 0.6990. So now I need to calculate the molar absorptivity. So using Beer's law, absorbance equals the molar absorptivity times the cell length times the concentration. I'm told the concentrations are up here, spectra concentration here of each compound. Here is my B, my path length, a mixture in, again, the path length. Okay, so the absorbance then, if I'm going to fit all this stuff together, and you can do this with a spreadsheet all the same. So I'm going to use this absorbance first. I'm calculating my molar absorptivity, 2022 wave numbers and 1993 wave numbers, again, A and then B. So I get 10170. 1971, 228.8, and 13980. Now we can work with the mixture. So the mixture, the absorbance at 2022 is negative log of the transmittance. The transmittance is 0.340. So how do you get that? Well, I'm told that a mixture had a transmittance of 34%. So 34% is 0.34 as a decimal. I'm looking for the absorbance. So the absorbance here is going to be 0.4685. Now do the same calculation at the other wave number. So I'm taking the negative log of 0.383 and I get an absorbance of 0.4168. Now I need to use these equations. I brought in the D equation as well, and I think it might be easier if we start highlighting. So if I call epsilon 1 of x, just call this epsilon 1 of x. And let's see, that's going to go here as well. Then I need epsilon 2 of y. So I'm going to call this epsilon 2 of y. That's going to go here as well. Then I need epsilon 1 of y, which is going to be this value. And I need epsilon 2 of x. Can't seem to write on that one. And that's going to be this value here. So then the A prime and the A double prime, that's going to be, let's see, let's call A prime is going to be the absorbance at 2022, and A double prime, it's going to be dark green, is going to be the absorbance at 0.4168. Now all we have to do is calculate. So the B is given to us, it's 0.00500 centimeters. So to calculate my D value, I take my B, 0.00500 centimeters, And I'm going to fill in the numbers that I have just highlighted. So I'm going to start 10170 times 13980, and then I will subtract my blue number 1971 and my purple number, which for some reason wouldn't highlight purple, but 228.8. So I get a D value then of 708628. I think that's enough significant digits. We can keep that. So now I can calculate the concentration of my X. X is going to be A. So the concentration of A in this case is going to be, let's see, I need my pink number, 0.4685 times my green number, my light green number, I should say, 13980 minus my dark green number, 0.4168, times my blue number, 1971. And then I'm going to divide all of that by 708628. And then I get a value of 8.08 times 10 to the negative third. Now, just as a disclaimer here, Harris seems to get 0.00911. I wonder if that variation is caused from rounding or lack of rounding, but that's a reasonable estimation for A. If you get 0.911, I'd love to know how you get it. So now I'm going to work on the concentration of B, which is my Y here. So the concentration of B will be generated by finding my dark green number, 0.4168, and multiplying it by my yellow number, 10170. And then I will subtract my dark pink or red number, 0.4685, times my purple number, which for some reason wouldn't highlight purple up there, so 228.8. Now, when I double checked this, I couldn't get that 0.8 to come across a second time, so that could be a source of my error. Again, it could be like in this value here, rounding versus not rounding. So for this value, I get 5.83 times 10 to the negative third molar, and Harris got 0.00468. Again, could be a rounding error. So again, Harris got 4.68 times 10 to the negative 3. That is a bit of a difference that concerns me. I would have to go back and double check this 6 different ways to see if I could find the error in the rounding versus not rounding. But that's how that is generated, at least.